Hello friends, my name is Kishan and welcome you in this video tutorial. In previous video tutorial we had seen a Spring Boot batch example, and there we have seen how we can read data from CSV file, and same data how we can write in the RDBMS. And here RDBMS we have used like MySQL, and we have written data into the batch, right? And every batch size we had specified as a 10, right? So this is the continuation of my previous video tutorial. If you did not watch my previous video tutorial, then I request you to go and watch my previous video tutorial. There we had discussed about this project, and when we looked into the database, then a Spring batch has created around 9 tables, right? And one of the tables which we had specified the DDL query in schema.sql, right? And this table was created and all data has been inserted. We read all data from the CSV file and we have written in this person table, right? So when you work with a Spring batch framework, then understanding of this DDL query is good to have, right? So here you see there are some of the tables which end with the underscore seq, that is nothing but the sequence. So there are 3 tables which ends with the seq. So this is the basically table which maintains the sequence, right? So in MySQL does not support you to create a sequence, right? So that's why a Spring batch creates a separate table to generate a primary key, and these tables has a primary key, right? And this primary key basically get Spring batch retrieves from the corresponding sequence table, right? So if you exclude the sequence table, then you have 6 tables, right? Like batch, and every table is prefixed with a batch underscore, right? So we have a batch job execution, batch job execution context, job execution params, job instance, right? Step execution context, etc. So if you go to the Spring batch official website, then they have given the explanation about this metadata schema. So they have given what are the tables are going to created in your database, and for every table there is a Java object. Like we have a Java object job instance, and corresponding table would be batch job instance, and similarly job execution we have a Java class, and corresponding table would be batch job execution. So if you later point of time, if you want to retrieve some column name, then you make use of these Java classes. So that's all about this schema overview, and they have given beautiful ERD, I mean entity relationship diagram. So how these tables are interconnected with each other, so they have given beautiful ER diagram over here. So here you can see here like a step execution ID, this is a primary key in this table, and this 2 table is connected with many to one relation, something like that. And here step execution ID is again primary key, and here job execution ID, this is a foreign key over here in this foreign key over here. So job execution ID basically which points to the which is going to refer to the primary key of the batch job execution, and similarly job instance ID is a foreign key over here which is going to point to the job this primary key of batch job instance. So this entity diagram you must understand. Now if you come to the bottom, then they have given example DDL script, and they have listed this DDL query is already there in your jar file. And if you go to the package, in this package, so let me go to the Eclipse, and here if you expand Maven dependencies, and if you go to the package it's called batch Spring batch core, and you expand this one, then if you go to this package on the bottom, they have given a lot of SQL file and which belongs to the different database. Suppose if you are using DB2, then you will have to go to this folder, this file, but we are using MySQL. So if you go to the MySQL, then all these DDL queries are listed over here, and that's the reason when you start your program first time, we had started our program first time, then this DDL query is triggered and this table is created in our databases. So this table will have in the jar file itself. So that's all about this description. Now every table, when you look into the every table, most of the table, not every table but most of the table, like these three tables basically, first, second and third, first, second and you have tables like here, you can see something like a column is getting maintained like version, which is basically long when you talk about the Java, but in MySQL this is a big int, and here also we have a version, right? Here also version. These three tables maintains the version column. And why? Because you can see the explanation. Basically Spring Batch basically follows the optimistic locking. So here they have given the beautiful explanation. Many of the database tables discussed in this appendix contains a version column, right? The column is important because a Spring Batch employs an optimistic locking strategy when dealing with the updates to the database. This means that each time a record is updated, the value in the version column is incremented by 1. When the repository goes back to try the save the value, if the version has changed, it will throw optimistic locking failure exception, indicating there has been a error with concurrent access. This check is necessary since even though different batch jobs may be running in different machines and they are all using the same databases, right? So to avoid the concurrency issue, they maintain this version column. Then we talk about the identity, means maintaining the primary key. As I have shown you, in MySQL does not support sequences. So that's the reason is in the case of MySQL, basically 3 extra tables gets created, which basically provides the primary key to these tables, right? So that's all about this description. Now when we talk about these tables like batch job instance, so here batch job instance has an ID, which is a primary key, and version already we had talked later. This has a job name and job key as well, and job name must not be null, and these job names comes from our project itself, right? In the configuration file we had specified this job name, right? So this will come from here, right? And same got inserted over here, and job key is also there. And what is job key? So basically they have described over here serialization of the job parameters that uniquely identifies separate instances of the same job from one another, right? Saying that job instances with the same job name must have the different job parameters and thus different job key values. They have given the beautiful explanation over here. Now we talk about the job execution param table. Then job execution param table has a lot of parameter, lot of columns value. Most of the important values are over here, like job execution ID, right, which is the foreign key, right, over here, which is pointing to the primary key of the batch job execution. So you can go through this description. Now if you come down, then we have a table is called batch job execution, which has several tables which is associated with the Java class. It's called job execution, and they have given different columns. Job execution ID, that's the primary key, and here also you have a job instance ID, which is a foreign key, which is pointing to the primary key of the batch job instance. And this table is really very important. Here we talked about this is a primary key, this is a version, already we have the job instance ID, which is again foreign key. Now they have given also a create time that basically maintains the time as a stamp representing the time that the execution was created. Similarly, we have a start time, which represents the that representing the time the execution was started, and this is end time when execution was getting end, and this maintains the another column is called status, and status value may be completed, started, and these values basically showing that I mean what is the status of your job execution, right? And this value is basically defined, that value has been defined in the batch status enumeration, right? Similarly, that defines the messages. In case some exception is arising, then they basically they log the entire stack trace almost. And when you come down, you have a job step execution, right? So a step execution is a very big table which maintains a lot of attributes, so you must go through this table as well. Now a step execution maintains a lot of information, like how many records has been read, how many records has been committed, how many records has been filtered, how many records you have written into the database, how many records you have skipped, right? Rollback count, like exit code, exit message, etc. Now come down, then you have a execution context table, job execution context, which is basically 3 columns. First column, job execution ID, is a primary key itself, and this is also defined as a foreign key at a time. Now here a step execution context, this is pretty straightforward, so you can go through this, and basically these two tables, basically job execution context and a step execution context, you must go through the explanation, right? If you look into the explanation saying that batch job execution context table holds all the information relevant to an job execution context. There is exactly the one job execution context per job execution, and it contains all the job level data that is needed for a particular job execution. This data typically represents the state that must be retrieved after a failure, so that job instance can start from where it left off. So sometimes your job gets failed, then you have to start from there. You have to start from the where that was failed at that time. So those things is retrieving from here, job execution context. And similar action is applied for the step execution context. So if your job get failed, then this will retrieve the information about the step execution context from this table, and that start from there itself, right? Regarding the archiving, you can go through this. Now if you come down the bottom, then they have given recommendation for the indexing metadata tables. So by default these scripts which we have seen over here does not apply indexes on the any column, but still if you would like to apply indexes on the any column, then you are ready to go, you are ready to proceed. And they have given the brief description about like a table name they have given a column, and how frequently this column is reading by the batch operation, right? So based on this information, if you would like to apply some indexing, I mean this, suppose this column you are using very frequently in the where clause, then you might be interested to apply some kind of indexes, so that this will improve performance of your batch operation, right? So that's all about this schema information. I hope you enjoyed learning this video. Thanks for watching this video, and see you in next video tutorial.